Nope. Ellipses. Nope. Okay. As far as ellipses are concerned, it's the same type of thing as parabolas. We're going to learn it one way, and then we're going to do it the opposite. Graph from information. So, everybody get your notes out. You ready? Alright, so let's just look at the basic form, and we'll go from there. X squared over a squared, y squared over b squared equals 1. So there's some things we need that they have to have. The coefficients in the numerator. In the numerator, okay, they have to be 1s, positive 1s. But first and foremost, the equation has to be equal to 1. So that's the first thing you actually need to do. And then your coefficients need to be changed to 1s. So I'll show you how to do that after a couple of examples, after the first example, I guess. Alright, so those two things are the most important thing before you even get started. And then another note is the larger number, in this case it's going to be a squared, is under the major axis. So if a squared, if the larger number was under this y squared, this would be a squared and that would be b squared. And then our ellipse would be, our major axis would be on the y-axis. So today we're doing ellipses that the centers are at the origin. Okay, just like the parabolas, the center, the vertex, we're at the origin. So the larger number tells you whether or not this is going to be an ellipse that looks like this or an ellipse that looks like this. Okay, horizontal or vertical. All right. Okay, having said that, let's take a look at a basic ellipse because there's some things we gotta find. Let's look at a horizontal ellipse. Okay. And put these things in here. First of all, these two things are called your foci. There's two focal points. And any point that is on the circle, that's right, any point that is on the circle, the sum of the distances from the focal points, that's d1, d2 distances, the sum of those two distances, that sum is constant no matter what point you choose on the ellipse. Now we're not going to be dealing with these two sums today. We're not going to talk about those. But that's how an ellipse is made. As you move around, these two distances change, but when you add them together, they are exactly the same. Okay? Now, having said that, so your page is going to get a little messy, so make sure you have a bigger ellipse to deal with, about like this. So let's put it on your paper correctly. Now, this right here is A0. And this one is negative A0 for a horizontal ellipse. So for a horizontal ellipse, this is B0, B, excuse me, and this one is 0, negative B. So now we know what A and B are. A, positive and negative A give us our major vertices. Our minor vertices would be positive and negative B. But notice they're in different positions, X's and Y's. It all depends on where they're at here. Okay, so we can find A and B by taking the square roots of these denominators. So let's make sure we understand certain things in our Pythagorean theorem. First of all, this is A. We all understand that. This is B. The focal points are at C. So negative C0 and C0. Those are your focal points on the major axis. This is a right triangle. This is not A, this is C. So normally in a right triangle we always say A squared plus B squared equals C squared. That's okay, but it doesn't have to be those letters. What are you doing in the Pythagorean theorem? You square the legs and you add them together, and that equals the square of the hypotenuse. That's truly what the Pythagorean theorem is. It doesn't matter what variables you're using. So you need to understand that this is C and that's B. So C squared plus B squared, or B squared plus C squared, like alphabetical. That equals this hypotenuse. This hypotenuse is the exact same distance as A. So B squared plus C squared equals A squared. The sum of the square of the legs equals the hypotenuse squared. So stop thinking of Pythagorean theorem as A squared plus B squared equals C squared. Stop thinking of it that way. That's very typical, but now we're moving on. This is where all these letters come from. Now there's 5 things you got to tell me, and we'll use this to start. So horizontal ellipse. The foci give me the coordinate of the foci. This is going to be positive and negative C, 0. Your focal points are on your major axis, so the horizontal ellipse is on the major axis. That's the first thing you got to tell me. It doesn't have to be in this order. One of the 5 things you got to tell me. Vertices. Vertices are at plus or minus A0. So how would those two change if we had a vertical ellipse?
Plus or minus and 0 B.
No, the letters stay the same.
0.
Instead of being on X's, they'd be in the Y positions. And we'll do an example with this. Okay. And then the let's see. Ooh, we forgot something. The eccentricity is C over A. And if it's close to 0, it's close to a circle. And if it's close to 1, it's elongated, more like an ellipse. Okay? So the eccentricity is going to be a fraction. I want to think about this. Here's A. As C gets bigger, as it goes closer and closer to A, it gets closer and closer to 1, right? And this makes this go smaller and smaller because it gets tighter and tighter and it gets really flat, like a normal ellipse. But as C gets smaller towards 0, 0 over A is 0, as it gets, if both C's are right in the center and you were going around, this would be a circle because you only have one focal point, right? So as this goes to 0, your eccentricity goes closer to 0. It's more like a circle. All right. So that's just what that means. That's just an understanding. But you have to tell me what the eccentricity is. So E is C over A. So you got to find C and A, which you have in the first 3 things. You don't even have B yet. Okay. Then somewhere in your homework, they want the length of the major axis and the length of the minor axis. So in a horizontal ellipse, what would be the length from vertex to vertex on this figure?
2 times
Yeah, 2a. Isn't this a? There's two of them, so 2a. That's the major axis. So the first four things, you only need a and c. What's the minor axis? 2b. So those 5 things, and then you got to graph it. Okay, pretty basic stuff. Notice that yesterday was really all algebra 2. Today is still algebra 2. Tomorrow's or next week will be algebra 2 until we get near the end of the chapter next week, and then we'll do this stuff with PreCalculus, meaning polar coordinates,
Hey, I work with polar coordinates.
all that good stuff,
Photoshop.
and a little trigonometry. Just 2 sections. 1 trig, 1 polar coordinates, stuff like that. And then we'll be done with the chapter. So the majority of the chapter, the first 4 sections, are really all algebra 2, this type of stuff. And then we're going to have 2 sections of really PreCalculus stuff. So the test shouldn't be too difficult. Just make sure you're paying attention on that extra stuff. All right, that's the basics. And if this was a vertical one, then what changes is just these 2. That just switches positions, and this is what it is. It's still 2a from the major axis.
Wait, why? I mean, would A be in the Y position then?
Yeah, these would be over here.
Okay.
These still stay the same. Okay. All right, let's do an example, shall we? Number 10. X squared over 16 plus y squared over 25 equals 1. First and foremost, is that correct? We have this. The coefficients in the numerators being positive 1. Yes or no? Yes. Is the equation equal to 1? Yes. Excellent. Excellent. You need a pass? Or are you good? No, I'm good. Alright. So once you have that, then this is what you do. What's A, what's B, and what's C? What is A? Yep. The larger number is A squared. And whatever it's under is your major axis. What is A squared under?
Y.
Y. So this is going to be horizontal or vertical?
Vertical.
Vertical. Good. Okay, so A is 5, B is 4. How do we find C?
Squared plus.
A, B squared plus C squared.
C squared is A squared minus B squared. And C would be the square root of that, right? Well, we already have A squared and B squared right here.
Oh, wait, I did that.
25 and 16.
Wait, so why is A the y line?
These are squared. So to get just A, you gotta take the square roots.
So why wouldn't A be 4?
Because A squared is always the largest number.
Would that be plus or minus 3?
Yes. Yes. To answer your question. Because you're going both directions. So let's answer these questions. Foci, Abby. Think. Focal points are on your major axis. First of all, what number do we need? C, which is 3. So what are our coordinates of our focal points?
Plus or minus 3, 0.
But our major axis is the y-axis,
Oh, so that would be 0.
so 0 plus or minus 3. Why is it important to know where the focal points are? If we did some applications, then it would be important, especially like orbiting moons and stuff like that. We're talking about space stuff. Understanding elliptical orbits. You can identify where your focal points are. What are they what's actually causing them to have an elliptical orbit? You can identify where that stuff's at. Okay. vertices?
I mean 5. No.
What's the coordinate?
Oh.
0, 5.
5.
Oops, sorry. Alright, so there's the major axis. Where would the minor vertices be? Because you do have to graph these. Where's the minor vertices? Yeah, 4, 0. And negative 4, 0.
You said they were the minor what?
Minor axis. They're not asking you to label the minor vertices like this. When they ask you for the vertices, just give them the major ones. But you're gonna have to graph, so you still need to know where the minor ones are at. Okay? Alright, it looks like a circle, doesn't it? Pretty close, but we know it's not. I didn't draw it accurately. So what's the eccentricity then? 3/5, I would say.
Yeah.
3/5. It's more than half, so we're closer to 1. It doesn't take much for it to look close to a circle. If you have an accurate graph, then you can visualize it a little easier, but it's more than a half, so we're closer to a circle than anything else. Okay. What's the next? Length of the major axis. What's the length of the major axis?
10.
Everybody know that? 10? Minor axis? Yay! Hey, congratulations! You just did an ellipse.
It's 2 times A for the major, 2 times B for the
Now that doesn't change between horizontal and vertical. A is A. A is always your major information. When we do hyperbolas, that changes. So you gotta make sure you remember which one is fixed and which one isn't. In the hyperbola, A always stays under the X, B always stays under the Y.
Does this get worse? Yeah, as we go on chapter 11. Because I feel like these first 2 sections are just like recap.
First 4 sections are algebra 2. This is algebra 2. You guys should have done this in algebra 2.
Oh yeah, definitely. I remember all this.
Yeah.
It's just,
So the first 4 sections are algebra 2. I said section 5 and 6. That's when it gets a little hard. But then that's it for this chapter. So you know, make sure for the test we really got this stuff down so that you can, you know, if you have a disaster in 5 and 6, you still pass the test. Yeah, but you should be able to do all right in the last 3 sections. Because there isn't really anything new to show you. We're just applying some of the things you were learning to progress from there, okay, in PreCalculus. We're not going to get into chapter 13, which is calculus. And I really wanted to because I wanted you to see that I think you'll think calculus is easier than PreCalculus. It's really the trigonometry stuff that makes students freak out about higher level math. It's not all hard, okay? Alright. Let's do a difficult one. I'll give you the hardest one I can find. Yes. This is the hardest one I can find. Now, you may think another one's more difficult, but this is up there, okay? This is number 22. 20x squared plus 4y squared equals 5. All right. What was the first thing I said you should do? Actually, I wanted you to do the other one first. What is it, you remember?
equal to
Yeah, I want the equation to be equal to 1. How do we do that? We divide by 5. I want you to do that first. And then we'll get our coefficients to be 1. So, now the next step. Here we go. So I want to show you something. You don't have to write this down. I want you to pay attention to what I'm showing you. In general, if I had this 2 over 3/5, how do you get rid of the fraction inside of a fraction?
Multiply by reciprocal.
Yeah. What are you really doing when you do that? You're really taking the 3/5 out of the denominator and putting it in the numerator. That's really what's happening. Okay? So if I said work this backwards, I could take this and take the reciprocal and put it in the numerator. Having said that, how do I put 4 in the denominator?
Multiply by 1/4.
Oh, wait, what?
You multiply by the reciprocal, let's divide it, meaning move the 4 totally out. Okay? So it's x squared over 1/4 and y squared over 5/4. It's manipulation. We really didn't change the value. Right? So what would you do to get this fraction out of here? You would take x squared times 4. Well, that's... I don't have to do anything to the 1 because I haven't really changed any values here. Okay? I just manipulated the way it looks. You've just never done this before. Now you know. You can move anything in your numerator to the denominator, just put the reciprocal of it in the denominator. And you're done. Okay? The number 8, you don't have to write this down. The number 8, isn't that 8 over 1? Isn't that the same thing as 1 over 1/8? Wouldn't you take 1 times 8?
Yeah.
Okay, there you go. Alright, so this works. So anytime you have something in the numerator and it needs to be in the denominator, put the reciprocal of it there. That's just the trick. Okay? So now you have the first 2 things that you needed. Guess what you got to do? A, B, and C. I'm just going to go ahead and write this. That's A squared minus B squared. Oops. So C. So let's figure these out. What's A? What's A squared? 5/4. It's already squared. And that's the typical error that students make. So when we start doing this backwards, don't put the A under the y squared or the x squared. Make sure you square it first. So A squared is 5/4, so I got to take the square root of that. What do I get? What's the square root of 1/4?
Yes. It's been a long
Okay.
day. It's been a long day.
Just stop talking.
Oh, yeah.
Not you.
Oh, me. I got that.
Alright, now watch this. You take the actual numbers because they're already squared here. 5/4 minus 1/4. What's 5/4 minus 1/4? Yes, very good. 4/4. What's 4/4? 1. What's the square root of 1?
1.
There you go, you got A, B, and C. Now everybody, give me the 5 things I want. Go. You don't have to, you have to graph it tonight, so you can use your calculator to figure out what the square root of 5 over 2 is, stuff like that. Give me 30 seconds. Who put it in the right place? Okay. You alright back there?
You know what I mean?
Yeah.
Yeah, I'm fine, why?
Here, just make sure you're just hanging out. You know what you're doing?
Fine. I got it mixed up.
Alright, make sure you have your notes with you so you can get it quickly. C goes with foci, A goes with vertices. Okay, E, that's just that over that. 1 over, radical 5 over 2. That's 2 over radical 5, which you have to rationalize your denominator.
2 radical 5.
Ta-da! Okay.
Majors 2.
Square root of 5. Yeah, square root of 5, yeah. Right.
Oh, sorry, B.
Wait.
Sorry. 1/2. There. Done it too many times.
Wait. Oh, I got this. I didn't have the last section. I got this. Check.
Got it?
Yeah.
Excellent. Well, good? Are you? Alright. So we can go on. Alright.
Yep, go.
Everybody's ready, right? You scared? No? No. Alright, I'll give you something easy. Okay. Find the equation.
Oh.
I'll make it easy for you. Give me the equation of that ellipse. Dun, dun, dun. And just like in your parabolas, they're going to give you pieces. I can't go through all the possible pieces. Oh, I guess I could, but I don't have time to do it in 45 minutes. I can't do that. So you just have to figure out what is it you have. You need A, B, and C. But it's possible that they'll give you X and Y, a point on the ellipse, and another piece of information. So out of the 4 things you need for you need 1, 2, 3, and 4 to figure out the whole equation. Okay? So as long as you have 3 of the 4 pieces, you're good. Or if it's just these 2, you only need one of them, A and B. But you got whatever they give you, you got to use what you've been taught to figure out the other pieces. Just like when we did the parabolas. All right. So what do you know and where does it go?
X squared is over 25.
X squared is over 25. Why?
What?
Okay.
Why? Oh, okay. Because the foci is, or foci, whatever. You guys know what foci is plot.
This is not foci.
Whatever. I don't know what to do with that. I know what vertices.
These are the major vertices.
Yeah, that's what I meant.
Are on the
And
x-axis.
that's A, so, and not.
Good. We got that right? Okay. And that's key. You gotta make sure, just like the parabola on the quiz, you guys were, some of you were off on which way they were supposed to go. All right, last one. I'm just picking one of these, just because I can't show you all of them. All right. So here we go. We'll do this one. This is number 38. Your foci is at plus or minus 5, 0, and the length of the major axis is 12. Give me the equation. No. Let me help you. Oh,
Next
wow, great.
Are there?
Cool. start with you. We'll let you answer the easy question. You want the hard question? Alright.
Did you ask us to give you the equation?
I want the equation of the ellipse that has that information with it.
Why can't we just go back to parabolas?
What?
Why can't we just go back to parabolas?
It's not
Oh, we gotta do hyperbolas yet.
I think this is easier.
This is easier.
Okay, Dante, quiet.
I think you think it's easier because you've done a lot of work with the parabolas. You kind of got your mind set on some of this stuff.
I'm just done. I don't.
You're just
I think
slowing,
Oh, no, I don't.
slowing down.
All the above.
Remember the length of your major axis is 2a. So a must be 6. Your focal points are c from the c distance from the center. So that's 5. So you have x squared and y squared. The question is, where does 36 go? Why is it under x? Because you're
the square root is bigger than 5. Wait, what? Oh, no, because that's the major,
you're saying the x-axis is the major axis.
Yeah.
How do you? That's what I'm asking. How do you know that's the major axis? What's in the x position?
the foci.
There you go. The foci. All right. So 36 goes here. What goes here?
11.
How do you know that?
I did the equation of b squared plus c squared equals
So b squared equals a squared minus c squared. So b squared equals, let's see, a squared is 36, c squared is 25, b squared is 11. Don't put the square root of 11 there. That would be b, not b squared. Very typical mistake. That's why I chose this problem.
Wait. Where am I?
We good? Good, because you just did today's and tomorrow's lesson.
Why is 36?
Hold on, back up.
Hang on. I was alright. Why is 36 and not?
Go to the bathroom.
What?
Why is 36 and under the x?
Because your focal point, just like yesterday, it helps to kind of draw it. Your focal point's a plus or minus 0, 5, 0. Well, the vertices have to be over here somewhere. Well, this is the horizontal. They're on the x-axis. So that means A has to be under the x. Okay?
It couldn't be the other way.
Right.
It can't be a 5.
Right.
And that's how they do that, don't they?
The focal point's, no, the focal point's on the inside of the parabola.
Yeah, but on.
They go the opposite way. The hyperbola is the same way, what you're thinking. Okay, your assignment, page, when you split it up, page 739, we're going to do 5 to 21 odds, I think. Okay. Have at it.